our side here is a symmetry, okay? And for the top of the domain and the side of the domain, usually Fluent will recognize these as a wall. And what you would like to do, since our domain is large enough and far enough from the body so that this wall here will have really no influence on the flow features around the car, we can put both of these as a symmetry, okay? And what this means, it's not that they're symmetrical and that we're going to mirror anything about this face or this face here. It just means that the symmetry condition in Fluent is going to be applied, which is a no shear stress wall. So it's same as basically picking just a regular wall function and then saying it has zero shear stress. So why not just name it a symmetry? So we're going to name this symmetry top and symmetry side. Okay, and now one more remains, and this is our floor or the road or whatever you want to call it. I'm just going to name it road. And we would like to kind of have those prism elements on the road as well. So we're going to include this in our program controlled inflation. Now, the default option for inflation for Fluent Flow is smooth transition, but I've kind of found a document on the internet which is best practice guidelines for automotive external aerodynamics with Fluent, and you can find this in the links in the description of the video. I'm going to put it there, and basically someone was nice enough to kind of outline all of the best methods that are used in mesh generation and kind of Fluent as a solver. So what they recommend here is using the inflation method of first aspect ratio and the settings of 5 elements, growth ratio of 20%, and a ratio of 5. So what we're going to do is what they said. So under smooth transition, click down and pick the first aspect ratio. And the defaults are going to be 5, 5, and 1.2, which is great for us. So under advanced options here, if you put this as yes, there's a bunch of them opened, and basically the only one that you would maybe like to upgrade is the smoothing iterations, and you can put these as 10, or I think the maximum is 20. So do that and put no back here. Okay, and now we can update our mesh again. So let's just zoom in for a before and after. Okay, and I'm going to update. Okay, so we have created our prism layer, which is going to kind of capture the boundary layer, and as you can see here, with the first aspect ratio picked out, there is a growth of elements in this direction, and the last prism element has a nice volumetric transition into the first tetrahedral, and this is kind of important because you do not want this to be any larger than the 20% growth that we have defined for our volume mesh. And with the smooth transition, it's much lower. This element would kind of maybe be cut in half, and this one would still be the same size. So leave this as Fluent guys recommended. Now, if we zoom back out, okay, you can see that it also grew some elements on our road. So what you can do to check kind of how your mesh looks, maybe in a cross section, I'm going to just zoom in slightly here, and you can click here and put in a new section plane. You would just kind of left click, hold, and then pull your line, and you can kind of put it in any direction that you want. I kind of want to cross the leg here and just see how that looks. And you would click the Z direction to look at your mesh from the front. Okay, this kind of looks very crap, and you would like to click this little pyramid here to show the whole elements. Okay, and now it's showing you the whole elements, and this looks kind of much better, and you can see how the inflation layer looks all around your body. Okay, And maybe we can check out how it looks near the floor here. And you can see that it kind of did a little compression when the elements got smaller. So everything is pretty much fine, except if you click the -x direction, you can see these elements kind of grow as we go further away from our body. And what you would like to do is, another recommendation from the Fluent Germany, is to create a volume control box around the body where we can limit our elements to a certain size, just like we did with the phase sizing function. And this is going to provide us with better controls later on, and to refine the mesh automatically and stuff like that. There are several ways of doing this, and one of them is to create it's called the sphere of influence. So what you can do is click on the mesh, insert, and another sizing function, and then you would maybe click your body here and check that, and then under here you can pick a sphere of influence, and now you would define a sphere center, and maybe we can just put this in a little vertex just to show you how it works. Okay, and let's say sphere radius 200, and let's say we're going to limit our elements also to 10, or let's say 500 here. Okay, and now if you clicked your update, okay, and it has created a mesh, so you can see that it just creates a kind of virtual sphere inside which the elements can be limited to a certain growth. But there is a drawback to this, and I can't seem to recall what it is, but I know it kind of disables your edge sizing functions and stuff like that, so we do not want to use that one, so we're going to delete this. And I'm going to show you another way with which we can refine elements in the region where we want them. So we're going to exit this for a while and go back into Design Modeler and create some additional geometry. So I'm going to edit this here. Okay, and now we're just going to put a kind of a box around our body inside which we can kind of limit the elements. So you would like to go into the YZ plane. I've already made a couple of sketches here. We can delete this one, and I'm just going to delete this one too, so there is no confusion. Okay, so YZ plane, click the little blue icon with the dot here, which is a new sketch, and you would go under sketching here on the left. You would create a rectangle, and let's zoom in a bit. So when you kind of get near your axis, it will create a little C here, so we can just click and drag. Now go under dimension, and we can just say, for example, we want this to be, let's say, 2000 millimeters. Okay, let's say 2500. And we want our vertical dimension to be, let's say, 500. Okay, so the Fluent guys, you can read in the document that they recommend to be half a car length in front, half a car length to the top, and a car length to the rear for the wake region. So we can just add some more dimensions here. You can see a little illogicality here. The vertical dimension is actually a horizontal one, but that's due to how the body was rotated in SolidWorks. So we can go to vertical now and click our vertical axis here and this edge here. So we can specify this to be a car length, which is our 1044 millimeters, and you can, well, basically that's it. It will be overdefined if we did anything else to it. So let's leave this box as is. Maybe drop this down to, okay, this is fine. And now you would click modeling, and from this sketch it's automatically going to create an extrude. If you just click extrude, you can see it the base object is a sketch 4, which is our sketch. And you can leave everything here with the direction normal and fixed and blah blah blah. And we would just try to create, let's say, 200 millimeters. And if you rotate a bit, you can see how far that's gonna go. Maybe look at it from the front. And we want it slightly more, let's say 250 or even 350. Okay, this is kind of fine, so it's the same to the side as it is from the top surface up. Okay, and just click generate again. And now we have our solid, which is going to be a body of influence in the meshing software. So this does not have to be changed into a fluid like the air domain was. We're just going to call this our car box and leave it as a solid. We can just add a freeze for later on if we do anything else. So that's a car box, and we're going to exit this. Go back into our meshing, click edit, and it's going to ask you, it's going to recognize that the upstream data has been modified, and if we wanted to reread, and we do want to reread. Okay, and it's going to attach the body now. And it is done. Okay, so we can see there is a solid here, and you can check under geometry we have our air and our car box. So right click mesh, insert, sizing, and for our geometry selection we want our body of influence to influence the air domain. So we click anywhere on the air domain and click apply, and then under the type here you would choose a body of influence, and as a body of influence you would choose our car box. And then again we can limit our element size, for example, to 15 millimeters, and leave the growth rate as default. So after those 15 millimeters it's going to continue growing with a 20% growth rate. So we're going to go under mesh and another update. Okay, the meshing is done, and as you can see it has limited the size of the elements inside our car box, but the car box itself as a body was not meshed, but it's still kind of hanging here. So you can right click on the car box and hide the body. Okay, do not suppress it, because if you suppress it, it's also going to suppress this body sizing function here. Okay, so just right click and hide. And now if we go back under mesh, you can see we have our 15 millimeters growth capped. I mean, our growth is capped at 15 millimeters. There are these sort of kind of weird little clusters of elements over here, but this is I think due to the fact that it's trying to our symmetry plane is getting into the way of the growth of the elements, but it's not really to be worried about. So this is okay. And what you would like to do now is kind of check your statistics maybe. And we can see here that our mesh is around 1.7 million elements. And you can check the quality of your elements here with the mesh metric. And you can either use element quality or all of these kind of here, but I like to use skewness. And you can read online all about skewness and what it is and what it means. But basically you do not want it to be over 0.95, and if it's over that, then the mesh is kind of catastrophic quality. So we can see our maximum here is 0.83, which is not ideal, but no, the Fluent as an unstructured solver is not going to complain about this. It can solve anything up to 0.92 or 0.95. But you can see our average here is 0.22, and that's kind of okay. So I will bring this back to none. We have our named selections for Fluent, and this will for now conclude our tutorial on meshing. However, maybe I can show you a few more things.